Okay, in this video we're going to look at negative indices. If we look at our notes, we can see that we have been given the formula 1 over a to the power n equals a to the minus n. What that means is if we've got an expression, if we've got something to a negative power, we can rewrite that as 1 over that expression but with a positive power. And working with positive powers is a lot more helpful when we actually need to do certain calculations. We're just going to have a look at a few basic examples first, and then have a look at a few more complex examples. In general, it should always be your strategy to try and write things with positive powers. For example, if we had x to the minus 3, if we were to apply the rule that we saw in the last slide, that's going to be 1 over x cubed. These things are entirely equivalent, but this expression here would be a lot more straightforward to work with if we had to substitute a value into an expression. If we had y to the minus 6, that is the exact same as 1 over y to the power 6. Okay, so we need to just ensure that if we have negative powers, try and rewrite them away such that we have it as a positive power. So it will be 1 over that expression with a positive power at the bottom. If we were to think about it the other way, let's imagine we were given this expression, 1 over g to the power 7, and for some reason we had to write this with a negative power. We would apply the rule 1 over a to the n equals a to the minus n. So I've got an expression on the bottom here. So if I want to have it on the top, it's going to be g, but then the power is going to become negative this time. If I had something like this, 1 over x to the minus 2. This time I've got a negative power on the bottom, so I'm going to try and exploit this property here. So I'm going to have x, then it's to the power of the negative of the bottom. So it's to the power negative 2, which is just the same as x squared. Okay, here if I was asked to write this with a positive index, one thing we have to note is that it is only the x that is squared here. It is not the full thing in the bracket, it is only the x that is to the power minus 2. So if we were to apply our rules as normal, we'd have x squared on the bottom, and this 5 would stay at the top, because the 5 is not attached to the power, only the x is. This would be slightly different if the question was this, if it was 5x to the minus 2. Because the full expression is to the power minus 2. If this was the case, we could then write it as 1 over 5x squared. Need to be able to differentiate between those two things to make sure we can do these competently. If we were asked this calculation here, 2x to the power 5 times 3x to the power 18, this is just going to combine all the skills I've learned so far now. So I would multiply my numbers together first. 2 times 3 is 6, and then I'm multiplying, that means I have to add my powers. So I'm going to do 5 plus negative 18. Doing that at the side, 5 plus negative 18, we're adding a negative, so that's the same as taking away. So that's going to be 5 take away 18, which is minus 13. So if I simplify this, it would be 6x to the power minus 13. But if I want to write this with a positive power, it's going to be 6 over x to the power 13. If I had an expression here, 3x to the power minus 2, and I wanted to find out what the value of y could be. Let's say the equation was y equals 3x to the power minus 2. And let's say I wanted to calculate y when x was 3. I have no strategy to calculate this. I have no way to calculate 3x to the, I've got no way to calculate 3 times 3 to the minus 2. I don't know what that is. But if I rewrite my equation as y equals 3 over x squared, I can then substitute in, and I'm working with positive powers. That's going to be 3 over 3 squared, which will be 3 over 9, which can simplify to 1/3. I would have really struggled to get the answer 1/3 from here without a bit of luck. So rewriting your indices that have negative powers with positive powers will help you in the long run.